We're given all sorts of problems right off the bat in Chapter 3, right after learning about e to the x. But all we really know right now is the power rule, where you take x to the a, whatever that is, you bring the a down and subtract by 1, and you get ax to the a minus 1. So if I have x cubed, that's going to bring the 3 down, and you're going to get x squared. If I have just x to the 1, or just x, that's going to bring the 1 down, and you're going to get x to the 0, and that's equal to 1, so you just get 1. That's the derivative. So we've only learned the power rule, and we've learned that the derivative, which they'll now write sometimes as d dx, but you can also write it as f prime of e to the x, is equal to e to the x. And that means the derivative of this is the derivative of this. Okay? Those are the only things we know right now. So when I look at these problems, I'm going to keep that in mind. Let's look at the first one, 2 to the 40th. Well, you can't take a derivative of this because there's no x. This is a number. I'm going to call it 5 jillion. And any number, its derivative is 0. So the answer to this is just going to be 0. It doesn't really matter what number they give you. The derivative of a number is 0. Somewhere on a graph, it's a flat line, as it's always the same number. And the derivative of a flat line, the slope is 0. Where'd that go? Too far back. How about this one? Negative 2/3 t plus 2. Since these are separated by a simple addition, they can be treated separately. So we take the derivative of this. There's an exponent of 1 there. So the t just goes away, and you're going to get negative 2/3. And what's the derivative of a number? 0. So negative 2/3 is our answer for that one. Done. Next question. Are you with me? In fact, I'm going to make like a blank screen to just copy because we're going to be doing so much erasing. Let's guess on the next one, x cubed here. See how they're all separated by plus and minuses? So we can literally just do 3x squared. We brought the exponent down. Are you getting tired of doing this yet? Minus 4, because x to the 1 becomes x to the 0. That goes away. And then what's the derivative of a number? What is the derivative of a number? 0. Here's our answer. Done. Paste that new beautiful tan bit. Next, e to the 5th. That's 2.7 to the 5th. That is a number. The derivative is 0. Any number, even e 2.7, especially rational number like pi, is still a number. Numbers to the 5th are still numbers. The derivative is 0. But the next one, 3/4 x to the 8th. Bring the 8 down. Call it 8 over 1 if you remember your fractions, right? 24 over 4x to the 7th. Well, this simplifies to 12 over 2, so that's going to be 6. So you get 6x to the 7th. Problem solved. Next one. Let's see how fast you can go do these if you know the rules. We don't have to use f of x plus h anymore, do we? Maybe we will, but the whole point of calculus is to not want to do that. So this one looks a little bit harder. 1.4 t to the 5th minus 2.5 t squared plus 6.7. Let's bring the 5 down. 5 times 1.4 is going to be what? 7? 14 times 10 divided by 2 is 7. So that would be 7t to the 4th minus 5, 2 times 2.5, t. What's the derivative of a number? 0. So this is our answer here. Problem solved. Next problem. That's the first batch. Now we have x squared, 1 minus 2x. We need to find the derivative of this. This is much more complicated, isn't it? There's multiplied functions, quantities. Not everything is added and subtracted, right? So we can't just use the power rule. But if I distribute it, that'd be x squared minus 2x cubed. Now they're all separated by simple addition, so this would become 2x for the f prime, and this will become 6x squared. Are you seeing it? You should see this one. Next, 2t. Don't forget you can go back and play this slow if I'm whipping through them, but we got a lot of examples for today. To the negative 3/4. Well, that seems like a ugly thing to write, but we'll try it anyway. Bring the negative 3/4 down. Negative 3 times 2, so we'll get negative 6/4 t to the negative 7/4. I subtracted 1. I'm not even thinking about it, right? So this will end up being negative 3/2 t to the negative 7/4. No real math necessary. I just subtracted 1 from 3/4. So I took 4 more quarters away and I ended up at negative 7. I'm not computing this. I'm just working it out. That's the right answer. Next one. Now we got something in the denominator. That's trying to scare you off. But if you remember right, my s looks a little like a 5, sorry, or a sigma. We can write this as negative 12 s to the negative 5. You know how to do this. Bring the negative 5 down. Negative 12 times negative 5 is 60 s to the negative 6. I bet you were thinking negative 4, eh? I do that all the time. Make sure you're subtracting. If you have a negative number, that should be getting bigger. That's the answer. This one's done. Isn't this better than having to write f of x plus h? It's already starting to become fun calculus. The next one, little sneaky. You see how this is a combined function under an exponent? You cannot just apply the power rule or distribute your exponents this way at all. You have to FOIL this out. So 3a plus 1 times 3a plus 1. We get 9a squared plus 3a plus 3a plus 1. So we get 9a squared plus 6a plus 1. Now everything is separated by simple addition or subtraction. So we can use the power rule. Bring the 2 down. You get 18a plus 6. Brought the 1 down and made this a to the 0, so it's just gone because that's 1. And what's the derivative of a number? It's 0. So this is our answer. And if you want to be really cheeky, you can write it as like this: 6 times 3a plus 1. Notice if you'd brought the 2 down and just said it's 2 times 3a plus 1, you would have the wrong answer. And the way you spot that is by seeing that this combined addition is within an outer function. It's not just alone like it is here, where it's actually out and apart. Okay, who's next? Who's next? Bring them on. What else have we got today? Where were we at? Oh, okay. There's another one. Let's FOIL it out right away. Why even think about it? Always try to FOIL. Since these are combined, not by simple addition, we're going to have to expand. We get 2x squared minus 4x. Right, that's this one, plus 3x minus 6. So I put those together, you're going to get 2x squared minus x minus 6. Let's take the derivative. Bring the 2 down. 4x minus, take the 1 down. 1, x to the 0 is just 1. What's the derivative of negative 6? 0. So here's our answer. Next question. C. Y to the negative 6. Well, C is a number. Pretend it's like a 2. Just ignore it. Bring the negative 6 down. Negative 6 CY to the negative 7. Done. Next question. If it was like 2 different Y's, that would be different, but it's just C, so that was just a number. How about this one? Can we subtract them? X to the 5/3 minus x to the 2/3. Look at what we have. They're separated by simple addition. They're not within some larger exponential function, and they're not like sine of this number or any other thing that affects them on the whole. They are separated, just subtracted from each other. So we can do them separately. Okay, so we get 5/3 x to the 1/3, or sorry, 2/3. Can't subtract thirds today. Minus 2/3 x to the negative 1/3. That's the answer. That is the actual whole answer. And if you want to, you can write it like this: 5x to the 2/3 minus 2x to the negative 1/3 over 3. Doesn't matter. That's the answer either way. Who we got? We got one more. The 4th root of t, that's ugly, minus 4e to the t. Okay, there's some tricks here. There are some tricks here. Let's first write t to the 1/4, because that's what the fourth root means. I don't use square roots because they're stupid. Use the exponent, minus 4e to the t. Now we can, these are separated, right, by simple addition. So we can bring the 1/4 t to the -3/4, just subtract 1 from the exponent. And then what's the derivative of e to the t? It's e to the t, so this stays the same. You don't bring anything down. That power rule does not apply to this. It's a different rule, right? We've learned only two things. That the derivative of e to the x is e to the x. And we've learned the power rule, which they write as something like x to the n, the d dx of x to the n is n times x to the n minus 1. You bring the n down and you subtract 1. Those are the only rules we know. We just whipped through an entire chapter section in a few minutes because we learned these two rules and we just apply, apply, apply. If there's simple addition, you can power rule. If you see an e to the x, his derivative is going to be e to the x. It's that simple.